and welcome everybody to our webinar today on Firestop. Today we'll be presenting the last episode of our webinar tri-series on Firestop, and this webinar would be focused on Fisher solutions for firestopping. Now before we begin, please use either Google Chrome or Firefox to access this webinar, and we will be taking up questions at the end of the webinar. And I would like to request you to use the questions tab to post your questions instead of the chat box. Right. So for those who are joining us for the first time, my name is Muzaffar and I'm taking care of Fisher Firestop in the Middle East region. I have been with Fisher for more than 5 years, and today I will be joined by my colleagues Ansel, working with Fisher as a specification engineer, and Marion, who is the International Product Manager in the Firestop department. Just to recap, in the first installment of this Firestop series, we had discussed some case studies concluding the importance of taking a balanced approach to fire protection, which should include the active as well as passive fire systems. And to understand better, we saw how fire behaves and understood the different stages of fire progression. Then we saw the Firestop as part of the requirement within the passive fire protections systems and the code requirements of the same. In the second episode, we talked about the system approach for fire stopping, where in all the elements of the system are to be considered while looking for a proper solution. We also discussed the different technologies behind the Firestop products, and finally, the standards for testing and certification was discussed in detail, including the EJ or engineering judgment discussions that we had. Let us continue with this presentation today, which is the final in our series, and we will be looking into the right systems or the solutions that we as Fisher would offer in the civil joints as well as MEP penetrations, and then we would discuss some concerns regarding applications, and finally we would wrap up the session by showing some examples of how passive fire protection worked, and question answer session will be at the end. So that we had covered the entire range and tried to do justice by giving as much of information as possible for Firestop. Right. So in the last episode, we had shown that we have a range of products which are divided into 4 main categories: the sealants, sprays and coatings, wraps and collars, and some special products. Now, many a times people would have this question: why are there so many different products, and why can't there be one product as a solution for entire fire stopping in a project? Now, we have seen that there are several types of breaches that are caused in a fire rated barrier. Now, each of this breach has its own different set of parameters. So you have different types of penetrants that are going through, and hence to address all of these solutions, all of these fire stopping requirements, we would need a range of solutions which would be addressing individual applications. So we would look at the applications that we face in day-to-day fire stopping, and we have divided that for simple understanding into civil joints as well as MEP services. When we talk about civil joints, we are talking about the joints between fire-rated members, fire-rated barriers, or sometimes, as in case of curtain wall, a fire-rated barrier and a non-fire-rated facade system. And when we talk about MEP services, we are talking about all the different types of penetrations that would be going through. And to invite, to discuss about the civil joints, I would like to invite Ansel. Ansel, can you take us forward
Yes.
in our quest for finding the right solutions for fire stopping in civil applications?
Sure. Thank you, Muzaffar. So coming to the first application that we generally come across in the field would be the head to wall joint. So this is a joint between a fire rated wall as well as a fire rated floor. Now we need to consider a few parameters while choosing the right system for it. So the conditions would be the aesthetics, like is your joint exposed? So you will need a material that would be compliant with the painting requirements as well, and also meeting with the color requirements as per the architectural plan. Similarly, you would also need to take care that there will be some structural movement within this joint system. So this is capable to withstand the movement, and mostly you need to take care of the aesthetics or the acoustics of the joint. So the most common solution we would propose would be our acrylic-based sealant called FIAM, Fisher Intumescent Acoustic Mastic. So the name itself says that it takes care of the acoustics and it's an intumescent material. As it is an acrylic-based material, you can paint over it, and it is available in white. You can apply the sealant with a thickness of 10 mm over a PE backing rod, or with a thickness of 5 mm over a stone wool backing. Apart from this, the movement is tested for up to 25%, and that would be enough for a normal head of wall joint. Similarly, we have another solution called the rapid fire seal, or the RFS 640, which is red in color. So this would be suitable for areas which are having a false ceiling. It has quite a movement capability of up to 50%, and this would be applied like a spray. So coming to the next slide. The other civil joints we would have to consider in this application would be the wall-to-wall and the floor-to-floor. The products we would propose would be similar as the previous application. In addition to that, we would propose an additional product that would be the fire-rated silicone, or the FFRS, which would be used for externally exposed fire barriers. Moving on to the next slide. It is very important to have a properly sealed room for the civil joints. In this video, you can see that an improperly sealed room fills up with massive amount of smoke very rapidly from the joint gaps. When the smoke is present, your visibility is reduced, and when the visibility is reduced, panic sets in, and your occupants or the building occupants will not be able to escape very easily. Also, it is known that apart from flames, smokes and toxic gases is the hazardous of all. So the joint must be properly sealed. Coming to curtain wall application, the main criteria here is the joint which is formed between a fire and a non-fire rated facade system would be approximately up to 200 mm. So the solution that we would provide in this area or the gap should have a sufficient insulation so that the glass does not break in a fire incident, and then close the gap in an event of flame. The proposed product would be the RFS 640 in this case, where there is a mineral wool backing and then a spray sealant over it. The thickness of the sealing required to reach a fire rating of 2 hours is 1.6 mm thick. When it dries, it would reduce the thickness to 0.6 mm, and this is capable of taking a movement of 5%. You can also use another product, which is the FFB or ES, but the thickness is slightly more than 2 mm. And we also have a dry type of system where you can compress the material, fix it using the brackets, and that's all. This material would be predominantly used even for glass facades as well as ventilated facades. So this brings us to our second category, that would be the rain screen facades or the cavity or ventilated facades. Now, rain screen system would be constructed with either a stone material or an aluminum composite panel sheet. Also, you could quite oftenly we see that ACP sheets are used. and these sheets provide an easy path for flames to pass and spread across the external facade. Now, these ventilated gaps are a requirement to have for a functional purpose. However, during the fire, this does not behave in a positive manner. So we need some product that would provide the ventilation during the lifespan of the building. When exposed to the event of a fire, it closes the gap. So we have a product called the Ficirestopping, which is having an intumescent strip which would allow the ventilated gap of 25 mm, and then when exposed to a fire, it expands and closes the gap behind the facade itself. We have an additional product, that is the FCFCL, which is placed vertically. So in the next slide, we would see an example of a facade fire, which is very common and regular these days. The recent one being the Epcot Tower in Sharjah, UAE, where the facade played an important role in the spread of fire. So providing a proper solution is paramount to ensuring safety of the occupants. So
Thank
here we
you.
come with an end of the civil joints for the fire stopping.
Thank you, Ansel. Thank you very much for giving us
Welcome,
a brief
Muzaffar.
on the civil joints. Uh, Civil joints applications are really, really important. It is very important to note that civil joints are continuous joints, and a proper solution there would ensure safety of the building occupants. Now, moving on from civil joints, we come to MEP services. And in MEP services, we have several penetrations. And the first common penetration that we look at are the pipes. And within the pipes class, we have the metallic pipes. So, Marion, can you take us forward in the metallic pipe solutions? What kind of metal pipes do we see on the usual projects?
Sure, Mustafa. Thank you very much for the introduction. So, first of all, for fire stopping MEP services, we always need to take a close look on what exact type of penetrations are going through an opening in a floor or wall. So for metallic pipes, on the construction site, you will find a huge variety, but metallic pipes are mainly made out of steel or copper. On the next slide, for metallic pipes, Fischer can offer a variety of sealants with different approvals. The two most popular ones that we can offer are the Fischer EMUS and the Fischer RFS Rapid Fire Seal. Both of them are tested to the UL testing standards and have multiple UL listed systems. The application for metallic pipes is usually very simple, as the advantage of a metallic pipe is in a fire that they stay integral and will not decompose. Because of that, we only need to close down the gap between the pipe and the opening, and the application is finished. We prepared also here a short video which shows the impact a proper Firestop sealant is doing around a metallic pipe compared to just using the standard foam which you often find on construction sites. And from the video, you can imagine on the left pipe, which is not sealed properly, how quickly the heat, flames, and the fire itself will spread from one part of the building to another, especially in comparison to the proper fire protection done on the right pipe. Now let's move on to another types of pipe we often find on construction sites, which are the insulated pipes. The choice of the right product is here strongly depending on the insulation material which is used. Mainly, we can differentiate here between three types of insulation, which are the stone wool, glass wool, or a rubber type insulation, as seen on the right bottom, just for example, like the Almaflex insulation. So as an example, if a pipe is insulated with a stone wool, this actually helps us under fire conditions, as stone wool insulates the pipe and stone wool stays integral throughout the fire, and thus it is way more difficult for the heat to transfer through a wall or floor. On the other hand, if you would have a rubber insulation, it will melt very quickly in a fire, leaving a bigger opening for the fire and flames to pass through. In this case, we need to use a different type of sealant. So the Fischer solutions for insulated pipes are, for example, the FIAM-US, which can be used perfectly around stone wool insulation, or the UFS, so the Universal Fire Stopping Sealant. For the rubber insulation, we can offer a very good special sealant, which is the FIGM, the Fischer Intumescent Graphite Mastic. It has a ULEU approval, and the graphite, which is contained in the sealant, makes it expand very big when it is exposed to heat. On the next slide, there is again a video which shows on the left pipe the use of a B1 foam, which you usually find on the construction sites, and on the right side a proper fire stopping, which could be, for example, the FIGM solution. What is important here to mention is that the insulation is completely the same, and you can see that on the left pipe the insulation is completely melted away. There's a huge gap where fire can pass through, and the solution or the sealant that has been used on the left pipe is not doing any good to keep the fire away. The last type of pipe I want to present to you are the plastic pipes, which we also very often find in the buildings, and they can be made out of, for example, PVC, PP, or PE. So what is the difficulty with the plastic pipes? In the event of a fire, the pipes will burn or melt away. So we need to use a product which is able to fill and close this resulting opening. For plastic pipes, Fischer can offer 3 different types of products, which are, first of all, a variety of sealants. So, for example, if the pipe diameter is not that big, we could use the UFS and the FIAM-US, just in comparison to the insulated pipes. If the pipe diameter is a little bit bigger, or we have a different type of pipe, we can also use the FIGM with the ULEU approval. On the other hand, we also can offer wrap strips or fire collars, which in the end, they basically all do the same. It just depends on the customer's needs if they want to have a visible or an invisible fire stop solution. So the next video shows the significant difference between a proper and an improper fire stop solution. So the pipe on the right has been fire stopped correctly using a fire collar, as you can see on the video. And the right pipe was just sealed using a standard sealant. And yeah, I mean, you can see it pretty easily. There's fire smoke coming through. The opening is completely open. The pipe is completely melted away. There's nothing left of it. On the other hand, the fire collar is, when we use the fire collar, there's not just a little bit of smoke coming out of the opening, but the pipe is still stays the way it is. The video on the right shows how a wrap strip works. So the strip contains this graphite material, which expands a lot when it is exposed to heat, which is then crushing the slowly melting pipe and completely closing down the opening. All right, so far for the pipes. But in a building, we not only need pipes, for example, for the water supply, we of course also want to have electricity. So now let's take a look at the electrical applications. In a building, we here find a lot of single or bunched cables, cable trays or trunkings, or even busways. I quickly would like to show you how we can cope with these different electrical applications, starting with the cable bundles. Cables are mostly structured of metallic lines on the inside and a plastic jacketing on the outside. So the product we use for fire stopping these cables needs to be able to cope with both of the type of materials. Perfect for these situations, again, are our two sealants, VMUS and UFS. For cable applications, we can also offer a special kind of product, which is the Fisher FBS foam barrier system, which has a UL/US and a UL/EU approval. This system comes in Firestop blocks and a Firestop foam, and it is perfectly used if it is necessary during the lifetime of a building to add additional cables, as these can just be pushed through the application, and it's still an approved solution. For cable trays, on the next slide, we have a little bit of different products, as mostly the openings for cable trays are a little bit bigger, as the cable trays are bigger, and there's also more cables running through the opening. In this case, products may be, for example, the RFS sealant, which you maybe will remember from the construction joints for especially head of wall applications. The RFS sealant is then installed on top of a stone wool backing material. If we have a floor application, like on the right picture in the top, it is easier to use the Fisher FFSC, so the Firestop compound or mortar, because it is an easier solution. You can just pour it in the opening and it's finished. On the other hand, for wall applications, we mainly use the Fisher FCPS board, so the Fisher coated panel system, in conjunction with a little bit of sealant around the cables. If you know that during the lifetime of the building, a lot of cables are going to be added or removed from the opening regularly, then Fisher can offer Firestop pillows, which can easily be installed and removed from the opening. Again, we have prepared a video which shows on top cables which have not been Firestop correctly. You can see the cables, the jacketing of the cable melts away, and there's a lot of smoke coming out of the opening. On the bottom, Firestopping has done correctly using a sealant which has been tested to the according standard, and there's almost no smoke coming through, so the passage of fire, smoke, flames, heat is prevented very good. Another type of penetrant we regularly find in buildings are metallic ducts for air conditioning or heating purposes. They sometimes have an insulation, or they just only the metallic. Depending on the type of duct and the size of the opening, we can use the sealants UFS or VMUS to close down the gap between the duct and the wall or floor. In some cases, if, for example, the duct is insulated again with a rubber type insulation, we then need to have a solution which is able to close down the gap of the melting insulation. In this case, again, we can use the Fisher FIGM, the graphite mastic, which expands a little bit more. On the next slide, you will find pictures of what we also sometimes find in buildings, which are the fire dampers, and they are installed in the floor or wall. So fire dampers allow the air to pass through under normal conditions, but will close down in a fire to prevent the passage of smoke. So here we usually only have a small gap in the wall or the floor between the duct and the substrate, and we can use, for example, a sealant like our VM, so the intumescent acoustic mastic, as a smoke seal. And for the last type of applications, we have the multiple penetrations. So I'm sure you know that in a construction site, in most of the cases, we don't have only one type of penetrant going through an opening, but we have what we see in the pictures, one huge opening where a lot of different types of pipes, cables, cable tray, different types of penetrants are going through a wall or a floor. For this, Fisher can offer mainly these two solutions, which are first on top, the FCPS, the coated panel system, or the FFFC compound solution, which can also be used around different penetrants. So here we use the system FCPS or FFFC to close down the opening, and then we will firestop each penetrant individually depending on what type of penetrant is going through the floor or wall. So that was it for the MEP services and all the fissure solutions that we can offer for that. Mustafa, I'm handing back to you.
We talk about Firestop foam. Basically, it is a product which is approved for certain applications, specifically for joints, and it does not have any application for head of wall, for MEP services, I'm sorry. And even when we talk about civil joints, if your joint width is up to 10 mm, then you can use the Firestop foam up to the complete rating that is required. But the moment the joint width increases, the rating falls drastically, where you reach a 50 mm joint width with the rating falling down to just 11 minutes. So we have to be careful on what product we propose and where we use it. The second thing is, which we commonly see on the project site, is where people have made an opening which is bigger than the required opening, and then they try to close it down by using just the mortar, just the cement mortar. Now, cement mortar, as you know, is a very bad product. When it tries to cure, it reduces in overall size, and by doing that, it generates a lot of cracks within itself. And when there are cracks, the cracks are not good for fire, and spread of smoke happens very easily. And especially even during a fire incident, the cracks develop further, and this results in a huge propagation of smoke. So the right solution here, as was discussed by Marion, was the Firestop compound to be used correctly to reduce the opening size, and then using individual firestopping, as we discussed, in a shape of an engineering judgment that we provide. Also, when we come across the project site, we come across the cracks which we see in sealants. Now, these cracks are generally developed due to using incorrect thickness of the sealant. So many people might have this feeling that in case I increase the sealant thickness, I would get a higher rating and I'm more safe. And this is also an incorrect understanding, because the more thickness that you have, the more non-uniform curing that the sealant will undergo, and because of that, you would have these surface cracks. Now, let me clarify one more point here. These sealants, being intumescent, are absolutely fine if they have some surface cracks on their body. However, because of the aesthetic and the appearance, this would not be a good idea to increase the thickness beyond the recommended thickness. Finally, it is very, very important to do proper tooling and proper finishing of the sealant. When you apply the sealant, you have to clean the substrate. Then you have to do a proper finishing and tooling to ensure that there is no air bubbles within the sealant. The air bubble, when it tries to escape, it generates these kind of air bubble appearance on the sealant body itself. The problem here is the sealant thickness at these locations will be lesser than required, and because of that, it might end up having a weak point where the fire can break through this barrier. Moving ahead, when we talk about ducts as a solution, we always need to remember that there has to have a retaining angle, right? So if in case there is no retaining angle, then it is not completely complying with the tested system, and we need to see if the duct size is within a small size, or there are certain tested systems without retaining angle, then of course we can provide a solution. But the basic thumb rule is the bigger the duct size, you need a kind of a restraining element or a retaining angle to ensure that the duct stays in place in case of a fire, and the sealant and the backing material can behave and prevent the passage of smoke and flame that we want to prevent. Right. Finally, we would like to show you some examples before we move on to the question answers, where we could see how the pacifier protection as a system prevents spread of fire within the property. So as you can see, in this case, where the fire door itself is also a part of pacifier protection, and it is with an add-on of sealant around the opening itself, has prevented the fire to burn away the paper that was just after the fire door. And this is how effective is when we do a proper fire stopping around the fire doors. Similarly, if you see in this image, this is the fire side of a fire incident in a warehouse. Now what you see here is a small window, and the other side of the window is this office. So you could see that the fire which happened in the warehouse didn't affect the office space because a proper fire stopping was done in the fire rated barrier itself, preventing the passage of flame and smoke through that fire resistant barrier. Another case which we have seen is in this building, which shows a more clear view where there was a fire incident on one particular floor, and if the fire stop was done in compliance with the requirement of the codes and the standards, and a proper application ensured that the fire was prevented from spreading onto the different compartments as well as different levels within the building. And thereby what you could see here is it had saved a lot of lives, it had given enough time for the rescue to arrive, and it prevented a lot of loss that could have occurred if the flame would have engulfed the complete property. But let us open the forum for question answers, and let me go through the questions tab to have a look at the questions that have been posted today.